Okay, so we have worked on one-step dimensional analysis problems, which is where you convert moles to mass, mass to moles, or moles to molecules, molecules to moles. So those one-step conversions, so I drew on the board, and there should still be on the board, a map, a mole map. So I'm going to just draw it here on this paper. So mole is what we're calculating. It allows us to count particles. So because of the mole concept, we can count particles. We can also know grams. Sometimes we need to know how many particles we're using, but we can't count those particles directly because they're so tiny. So we use grams, and what allows us to convert to particles is the use of the mole. So this is what we're looking at. So for the last 4 days, we've been dealing with just mole to particles, particles to mole, or mole to grams, grams to mole. So anytime you have moles and you're going to something, you're going to multiply. To get to particles, it's always by Avogadro's number, which is 6.02 times 10 to the 23rd. And as a reminder, when you put that in a calculator, it just looks like this. And you hit the double E button once, and then you just put 23. Notice I didn't put any carets, no multiplication, nothing like that. If I have moles and I want grams, okay, so if I'm going from moles to grams, I'm going to multiply, and that's multiplying by the molar mass. So remember, molar mass is whenever you add up all the masses of your elements together or to make up the mass of your compound. Sorry. Anytime I have something else that I'm going to moles, so let's say I'm going from grams to moles, okay, I'm going to divide. And so the conversion factor between grams and moles is your molar mass. If I have particles and I want moles, so I'm going this way. Okay, so I have particles and I want mole. I'm going to divide, once again, by 6.02 times 10 to the 23rd. Okay, so this is the map that's on the board. What we're doing today is we are combining it. So we're going to combine. So these are called two-step dimensional analysis. And it's just because there's two steps. You have to use two different conversion factors. So this is like whenever you're asked, you look in your problem. So example number 1, which if you flip your page, you have your worksheet. So this is where you're showing all your work for this worksheet here. Notice how on this, it does say show your work on this page. No work equals no credit. The table is for you to calculate your molar mass. Calculations must be shown on the side. You do not have to set up dimensional analysis. You can follow the foldable and or the map. So some people do dimensional analysis. Some people just follow what the foldable or the map says. And the foldable you have in your notebook, and you should know how to use that. I don't think I have any more copies. I don't think I have any more copies that I can show you while I'm working this on here, and I don't. Okay, so here we go. So like example number 1, notice how it says how many molecules. So this is what I'm looking for is molecules. And it says I have 90.1 grams of water. Okay, all of them are going to give you a formula. You have to have a formula. Okay, so we just did it for water. Water is H2O, right? Notice I've got molecules and water. So I want to know how many molecules. So molecules is a type of particle, and I'm given grams. So I got to go from grams to particles. So that means I got to go from grams to moles first. So I got to follow this arrow. Once I'm at mole, I got to go from mole to particle. So I'm going to follow that arrow. Okay, so this is the route I'm taking. So example number 1, this is particle to gram. Okay, so to kind of help you out here. So particle to gram. Because grams is part of my problem, you can't see this, so I put particle and gram. Because gram is part of my problem, what does that mean? That means you have to calculate molar mass. Must calculate molar mass, and I'm going to just abbreviate with MM. So I left you this nice little box to calculate your molar mass. So in this problem, it's H2O. So I have hydrogen, I have oxygen. There's 2 H's, there's 1 oxygen. You must use the numbers off our periodic table. So hydrogen is 1.008, oxygen is 16. Total mass of element, so 2 times 1.008 is 2.016. 1 times 16 is 16. Molar mass of the compound is 18.016. Okay. Now we're going to do our math. So I'm going to just do it based on the map. So I'm going to just show you the map. So we're starting at particles. Wait, no, we're not. This is, guys, I told you wrong. Question wants to know how many particles. We're going from grams. We're given grams. We're going to particles. That is my bad. Okay. See, I make mistakes too. So I start with grams. So I look at my problem. My problem told me I had 90.1 grams. So I'm starting with grams, 90.1 grams. I gotta go from grams to mole first. So it tells you to divide by molar mass. So I'm gonna divide by my molar mass, which is 18.016. Then that gets me to mole, and then I go from mole to particles, and that tells me to multiply. And I'm going to just put what you punch in the calculator. That way y'all don't get confused. So that's the double E button. So I'm going to put this in my calculator. So here's my calculator. Okay. So 90.1 times 18.016. Let's see if I can darken this one. Maybe you can see it. Okay. So 90.1 times 18.06 times 6.02, you hit the double E button, which is by the letter A once. So it just puts a little E. And then 23. Looks like there was something extra there, so let me get rid of that. Times 6.02 double E 23. There we go. And we're going to round this to 2 decimals, so it comes out to 9.77. There is a letter E, so that stands for times 10 to the 26, and that would be molecules, because it asked us for molecules, so we're going to label it molecules. Okay. So that's example number 1, which if you look on the paper, for those of you that like doing dimensional analysis, it set up dimensional analysis. So I started with grams. So my next had to have grams on the bottom, moles on top, and so that's molar mass that goes on the bottom. So grams cancel. Now I had to have moles on bottom, particles on top, or molecules, because that's what it asked for. So molecules type of particles, put that number with it, and then that cancels out, and you get your answer. Okay. How did they get such a weird number? So let me double check. 90.1. Oh, you know why? Do y'all know why I got a weird number? This is not the answer. Okay. Teacher makes mistakes. 90.1 divide by, because there's a division there, 18.016 times 6.02. 6.02. Hit the double E button once, 23. Enter. There we go. We want 3.01 times 10 to the 24th. That makes much more sense. Okay. And so that's what they got. That's what we got, and that's what they got. Okay, so that's example 1. Sorry for the mess ups. On example number 2, so what is the mass? So we're looking for grams. And 3.01 times 10 to the 23rd molecules. So in example number 2, we're given molecules, which is a type of particle, and we are asked to find grams. Once again, because grams is something we're being asked for, that tells me right there, must calculate molar mass. So that's the first thing I'm going to do. So example number 2, it tells us that we're doing it for ammonia. Ammonia has got nitrogen and hydrogen. There's 1 nitrogen, 3 hydrogen. So nitrogen is 14.007. Hydrogen is 1.008. So that's 14.007. 3 times 1, nope, not answer. 3 times 1.008 is 3.024. You add that up, we get 17.031. Okay, now I just follow the roadmap. So this time I start at molecules and I'm going to grams. So I've got to go particles to moles and then, then moles to grams. So I'm starting molecules. It tells me I have 3.01 times 10. So once again, I'm going to just put what you punch into the calculator because I don't want y'all to get confused. Okay, so 3.0, remember that this double E just means times 10. So we do that. So we go from particles to moles. So to do that, I need to divide by 6.02 times 10, to the 23rd. Okay, and then I'm at moles, so then I go from moles to grams, so I got to multiply by my molar mass. So multiply, molar mass is 17.031. Now we're going to put this in the calculator correctly. 3.01, double E button once, 23, divided by 6.02, double E button once, 23, times 17.031. And you get 8.52 because we're going to round to 2 decimals. 8.52, we're looking for grams, so grams is our unit. Okay. And if we look here, if you did dimensional analysis, this is how you do it. So molecules is on the top. So that means your next train track, because remember we talked about train tracks. So if we want that unit to cancel, it's got to go on bottom. And so moles and particles, so that means this was a particle, so mole goes on top. We're not done yet because we don't want moles, we want grams, so then we draw our next train tracks. So molecules are gone. Now we need to cancel moles, so we put mole on the bottom, and I got to go to grams, so grams has got to be on top. And then you just fill in your conversion factor. So the mole opposite of mole with the particles is this number. Opposite of grams with moles is the molar mass. And then this divided by that times that. The numbers on top you divide, the numbers on bottom you multiply. Or no, numbers on bottom you multiply, numbers on top you shoot. Numbers on bottom you divide, numbers on top you multiply. Okay, if it's on top, multiply. If it's on bottom, divide.